So we'll go ahead and move on to session 3, go over the sustainable management criteria and the monitoring network. So to start off, we have 6 sustainability indicators. As you can see on the screen, we have groundwater levels, groundwater storage, water quality, land subsidence, depletion of interconnected surface water, and seawater intrusion. Now these are the 6 sustainability indicators that are part of the GSP, but if we're able to prove they do not apply to our area, we do not need to set criteria for them. For example, we do not need to set any criteria for seawater intrusion because we are not near the ocean. So since we're far enough away from the ocean, that is one indicator we do not need to worry about. And I'll discuss a little bit later, but we are also not setting any sustainability indicators for depletion of interconnected surface water. So that leaves us with groundwater levels, groundwater storage, water quality, and land subsidence that we are setting sustainability criteria for. So a little bit of background on what's going to be included for the sustainability criteria for each sustainability indicator. We will set minimum thresholds, undesirable results, measurable objectives, and then there will also be an overall sustainability goal for the GSA. Now for the criteria, it must be agreed to and be consistent within the 7 GSAs within the basin. So there had to be coordination on the methodology used to set the criteria and also what is considered an undesirable result. So we're only saying this for the 4 sustainability indicators that apply to the McMullen area GSA. This table shows the sustainability indicators. As you can see, the seawater intrusion and surface water depletion have been crossed out since we are not setting criteria for those 2 indicators. So for each indicator, it shows the metric, how it's going to be measured, and what is considered an undesirable result. For example, for water level, the metric is groundwater elevation. So we'll be measuring groundwater elevation to determine if there's been chronic lowering of the groundwater level. And an undesirable result would be considered chronic lowering indicating significant and unreasonable depletion. And significant and unreasonable is defined by the local area. So in this case, MAGSA came up with the definition for significant and unreasonable. And also have the metric and undesirable results shown for the other 3 indicators. So we're going to start with the water level sustainability criteria. So there's 2 bullets on the screen. The top one is for the entire Kings Basin, and the bottom one is specific for MAGSA. So for water level, for the Kings Basin, it is the GSAs within the Kings Basin have defined the undesirable result for groundwater levels to be significant and unreasonable when either the water level has declined to a depth that a new productive well cannot be constructed, or when the water level has declined to a depth that water quality cannot be treated for beneficial use. It's good to keep in mind that this is for the entire Kings Basin. So there's a lot of different geographical factors that come into play. So for example, in North Kings along the east side, there's bedrock. So part of the reason why they had in their water level decline to a depth that a new productive well cannot be constructed. Don't want the water level dropping so low that it hits the bedrock and that area goes dry. Doesn't necessarily mean that same criteria applies to MAGSA. We don't have bedrock that shallow. We have the Corcoran clay, but a lot of the criteria set, which I'll show in a couple of slides, is above the Corcoran clay. And the second part, for decline to depth that water quality cannot be treated for beneficial use, there's areas within the Kings Basin where in certain aquifers where there's multiple clay layers and multiple aquifers, there's some that have bad water quality. So they want to make it so you keep productive wells out of that aquifer zone so that you have good quality water. So taking that, MAGSA took it a step further to define undesirable results within MAGSA, which is when a third of the wells, or about 8 of the water level monitoring network, drop below the minimum threshold for 2 consecutive years at the same well. So we wanted 2 consecutive years in there to make sure it wasn't a fluke reading, to verify that the water level is in fact dropping and it's dropping below the minimum threshold. If it drops below the minimum threshold 1 year, then rebounds and come back up, that is not an undesirable result. It has to stay below the minimum threshold for 2 consecutive years. And we wanted to make sure it was at the same well to keep it consistent, make sure it's specific to that area. So now I'm going to talk about how we set the minimum threshold and measurable objective. This is a generic graph. As you can see, there's on the left it's depth to groundwater, but we didn't provide any numbers because this is a generic graph. Just to show you the process we went through for all the groundwater level monitoring wells. So the first step in setting the criteria is we looked at the historical data, which are all the blue dots on the left-hand side of the graph. Using the trend of the historical data, we took that rate of decline, so how much it dropped per year, and took it from the last measured fall reading and extrapolated it out to 2020 to estimate what the water level is in 2020. Now I know it's 2019, but it takes time to go through all the data, so when we're creating the plan, the most recent data point is 2017. So as mentioned earlier, in the 5-year updates, we'll update these graphs with more recent data. But for this plan, we took the fall reading of 2017, took that rate of decline, extrapolated the water level out to 2020 based on that rate of decline to estimate what the water level in 2020 might be. So from that water level in 2020, we have applied a rate of mitigation similar to the rate I talked about in the water budget. We want to address 10% of the problem in the first 5 years, 20% in the next 5, 30% from 2030 to 2035, and the final 40% from 2035 to 2040. So this is applied to the rate of decline. So the ultimate goal is in 2040, our rate of decline should be the measurable objective, which is hopefully 0. It's not decline on average, not declining. So based on that rate of decline, we came up with a water level in 2040, what that water level is, what that water level measurement in 2040 is the measurable objective. So that's why we have the measurable objective line at the 2040 water level. From there, we had calculated an operational flexibility. The group, the MAGSA GSA Technical Committee, wanted it to be based on a 5-year drought. So there are 2 options on how we calculated the operational flexibility. The first option is based on the recent drought, so from 2012 to 2016. What that rate of decline was, we times that by 5 for a 5-year drought, and that was our operational flexibility. Now in some areas that didn't work, like up by the river. In some areas there was even a positive rate of decline over the drought period. So for those instances, we took the historical rate of decline, multiplied it by a factor of 3, and we multiplied it by a factor of 3 to get a rate of decline that would be similar to the rate of decline during the drought. And then we took that rate of decline times 5 for a 5-year drought. So whichever provided the greater operational flexibility was used, and that's how we set our minimum threshold. As you can see on the graph, there's also a line for undesirable results. It's shown below the minimum threshold because there is some discussion within the Kings Basin that a true undesirable result may not be where the minimum threshold is set. And that conversation stemmed from where we have our minimum threshold, we still have a decent amount of water in the aquifer before we hit the Corcoran clay, for example, in the MAGSA area. So since we have so much water, an undesirable result may be when the unconfined aquifer is dewatered to the point where you can no longer pump in the unconfined. But we're keeping the water level. The deepest minimum threshold in MAGSA is a little over 300 feet. And the Corcoran clay ranges from 450 to 550 feet, and that's depth below ground surface. So we still have between 100 and 200 feet of water below our minimum thresholds within MAGSA.
Maybe if I can chime in, our minimum threshold number is more of a minimum threshold for our operational range. We still would like to maintain sufficient cushion there, not to bump up against a significant and unreasonable undesirable result. That's really what the black line is. That's where that undesirable result, which is loss of water storage or declining elevations, obviously is an undesirable result. And the quicker we can stop that from happening, the better. But it doesn't reach a significant and unreasonable definition under the law until such time as it begins to really, really affect our capital assets and our ability to operate on the surface, massive subsidence, et cetera. So we're staying well above that, giving ourselves that insurance policy and trying to land this airplane in an area that's much more sustainable over a very long period of time rather than trying to do anything to the minimums themselves.
Yeah, it was also discussed with the McMullen Technical Committee. We wanted to set the minimum threshold at a point where we could recover back up to the measurable objective. So if we do go to the minimum threshold, we wanted to make sure we're able to rebound and bring the water levels back up to the measurable objective, because ultimately we want to be sustainable around the measurable objective. And the water level may go above the line, go below the measurable objective line, but on average should be at that water elevation that was calculated at the well. So that was also taken into consideration on where we set our minimum threshold, because we could have set it lower, but then we might not have been able to come back up to the measurable objective. And that was the ultimate goal, was to be sustainable at that measurable objective elevation. Any questions on the methodology before I move on? I know I kind of went through a lot of information. No? Okay, so here's a table that might interest you. So on the left we have the MAGSA well ID, and on the next, in a couple slides, I'll have a map with where those wells are located. The second column is the distance from the 2017 water elevation to the measurable objective. So that's how far the water level will drop from the 2017 elevation to the measurable objective. And the last column is the distance from 2017 water level to the minimum threshold. So that's how far the water level dropped from the 2017 water level to the minimum threshold. So the MAGSA well IDs are based off of the township and ranges. So the 13, 1, 2, and 3 are along the northern part of MAGSA, along the San Joaquin River, and then the 16, 1, 2, and 3 wells are near the southern part of the GSA. So for the measurable objective, the water level will drop anywhere from 18 feet to about 65 feet, and the water level to the minimum threshold will drop anywhere from 36 feet to 120 feet towards the southern part of the GSA.
I think it's important here to really take a moment and think about this also. There are some folks who reacted to Sigma and said, oh my goodness, we have to flatten out our hydrographs right now. We can't have any additional loss. And the answer to that in MAGSA is a simple no. On the left column is what we actually expect to be the continued drop in water elevations in our wells at those locations to meet our absolute planned goals, our targets. And so what we're really looking at in the right-hand column is what's represented. There's a fairly substantial deviation from that, which will trigger some additional management actions and so forth. But if the plan goes the way we'd like it to, in a perfect world, that left-hand column will actually be the 2040 elevations for our wells if we're successful, and 100% success will be represented by those numbers. So those will be kind of our base to compare against as we're going forward to see how we're tracking. And that's really what it is. And when you see the map, you can kind of correlate the two. You'll see that MAGSA is, slightly wetter in the north than it is in the south, and so we don't grade the north and the south the same, but in concept they're the same, but not in numbers.
So before I show the monitoring network map, I'm going to go over the storage change sustainability criteria. The reason for going over this before I show you the map is we're using the water level measurable objective and minimum thresholds for storage change calculations. So within the Kings Subbasin, there's an estimated storage change of about 1.8 million acre feet. That's from spring 1997 to spring 2012, which averages to about 122,000 acre feet per year. So for storage change, an undesirable result would occur if the total amount of water in storage was less than the estimated amount of groundwater in storage below the minimum thresholds. So what we're saying here is we don't want the water level to drop below the water level minimum threshold. We want to keep the volume of water below the minimum threshold within the aquifer. So if the storage change drops to below that minimum threshold line, that would be an undesirable result. So as long as the water level stays above the water level minimum threshold, there is not an undesirable result for storage change. So we're using the water level and the water level monitoring network for the water level criteria as well as the storage change criteria. So this is the monitoring network for, as I mentioned, the water level and storage change criteria. So along the north, you can see the 13-1, 2, and 3 are near the river. And then the 16-1, 2, 3, 4 are along the southern boundary of MAGSA. So I'll give you a minute to take a look at the map and then see if there's any questions.
No questions.
Any questions? Okay. So we will move on to the next sustainability indicator, which is the water quality. So along the top, we have an undesirable result determinations will be based on one of these two options. So the first one is the degradation of water quality to exceed the maximum contaminant levels or the California potable water standards, where concentrations of chemicals of concern were historically below the MCL. So what this means is there are certain drinking water standards that the California has set for drinking water, and if water has historically been of good quality and below that level, if it goes above that level, it is considered an undesirable result. Now, in some areas, it is understandable that it might already exceed that level that California has set. If that's the case, we are not responsible for improving the water quality to below the MCLs. So that's where number 2 comes into play, where there's a significant increase in groundwater degradation, where concentrations of chemicals of concern were historically above the MCL. So that's basically saying where we already exceed that contamination level set by California. If it gets a lot worse, that would be an undesirable result, because this is about the degradation of water quality. And then the second bullet is what MAGSA set as an undesirable result would be when 6 out of the 12 represented monitoring wells have reached either of those two criteria for 2 consecutive years at the same well. So like I mentioned with water quality, we did 2 consecutive years to make sure that there's no fluke readings. So takes out human error, and if it stays as an undesirable result level for 2 years, then have to reevaluate that area.
If I could jump right in here too to kind of add to that, as Lynn stated, it's perfectly clear, but I'd like to kind of reinforce that. MAGSA has the good fortune of having fairly high quality water relative to some of the other areas of the subbasin. And so MAGSA's prime concern will be, of course, that in trying to achieve sustainability through all of our sustainable management criteria, we don't want to do anything that will have a negative impact on that, on the quality of water. So our main purpose will be to monitor closely how our water quality is doing and try to make sure that we don't do anything that will do any harm to that good high quality water that we're experiencing at this point. So water quality is not a critical element for us as it is in some areas, and we have the good fortune of not having to deal with a lot of filtering and cleaning up of some of the polluted waters that some of the other areas have.
So this slide shows the criteria we have set for the McMullen area. The measurable objective and the minimum threshold are the same level, which is the California maximum contaminant level that we talked about on the previous slide. So the chemicals of concern on the left-hand side are the chemicals we will be monitoring within MAGSA, which include arsenic, chloride, manganese, sodium, uranium, nitrate, DBCP or dibromochloropropane, and then 1,2,3 trichloropropane or TCP, and then total dissolved solids. So on the right-hand side is the standard set by California. The numbers with 2 stars, which is chloride, and TDS is a secondary MCL. So the primaries are required, the secondaries are recommended. And then the 1 star for manganese is a notification level. So there's no required contaminant level set by California. It's more of a guideline.
And these constituents are identified not because they're a problem per se in MAGSA, but they are constituents that have appeared on some water quality analyses that have occurred over the last 15 to 20 to even 25 years. We've taken this out of some databases that are historical databases. Much of the alphabet soup at the bottom is a lot of it has to do with some legacy fertilizers and herbicides and insecticides, which are no longer present but still remain as a legacy constituent within the soils and some of the aquifers. But again, none of our numbers on these particular constituents are particularly problematic in the scheme of things, but those are the ones that we want to keep track of since they have been noted in MAGSA over the historical periods.
So this is our monitoring network map for water quality. The way we decided which wells we would monitor was we used an online database called Gamma, and we selected the publicly available wells as well as the landfill wells, and these are the blue dots are the public wells within MAGSA, and the green dots are the wells at the landfill. So we wanted to make sure we had at least 6 wells for our undesirable result criteria. So 6 out of the 12 wells drop below the undesirable result definition, because if we had 4, then the landfill could set that criteria all by itself. So we want to make sure there was more wells included than just the landfill wells in that definition.
And you look that we have monitoring that goes from the top of the map to the bottom, but we also have noted 3 specific areas where we have a higher concentration of residents using domestic water supplies. That the first one at the top being Alkali Flats. It's just west of the dump. knock on wood and hope for the best for the future. The landfill has done an excellent job of capturing and sequestering any of the chemicals at the landfill, and so that water quality remains high for the Alkali Flats folks. And then down near Raisin City, there's both the Perry Colony and Raisin City. Raisin City actually is supplied water by the county service area that's set up in that area, but their water quality continues to be high as well. So again, we're fortunate at this point to have good quality water, and our residents are not being subjected to any significant degradation in their domestic water, which is a good thing. And our charge will be to make sure that continues to the maximum extent that we can control anyway into the future.
Are there any questions on water quality before we move on to land subsidence? All right, moving on. So for land subsidence, the criteria for an undesirable result related to land subsidence will be the significant loss of functionality of a structure or a facility to the point that due to subsidence, the feature cannot be operated as designed, requiring either retrofitting or replacement. So at this time, currently, McMullen doesn't have too much surface water infrastructure. There's a couple canals, but the historic subsidence doesn't seem to have impacted them historically. But part of this definition is that, as we'll talk about later, we've identified several projects to build within the McMullen area GSA, and we don't want land subsidence to impact those projects. So when they get designed and constructed, we want to make sure that they'll be able to operate as intended for the lifetime of the project. So the top table shows the minimum threshold. We have an annual land subsidence rate as well as a maximum cumulative subsidence rate. So for minimum threshold is 12 inches per year over an area of 36 square miles, and cumulatively no more than 5 feet over 20 years. And for the measurable objective, we also have an annual subsidence rate and a maximum cumulative subsidence rate. So the measurable objective is 6 inches per year over an area of 36 square miles and no more than 3 feet over 20 years for the measurable objective. So the 6 inches per year for the measurable objective is the historical subsidence rate that has been seen within MAGSA, and that was doubled for the minimum threshold just for some operational flexibility. But we also didn't want subsidence to drop too far, which is why we have that maximum cumulative subsidence rate to keep an eye on the GSA area. So we will be using 2 different monitoring networks for land subsidence within MAGSA. The first one is KRCDS subsidence monitoring stations. There are only 5 within MAGSA, and they're spaced out. So we'll use this to get actual data in specific locations. From the colors, the red triangles along the western side of MAGSA are a maximum of 1.5 feet of subsidence, and this is for change from 2013 to 2016. So the orange is 0.45 to 0.6 feet of subsidence, and then the green triangles are less than 0.14 feet of subsidence. So since there are a bunch of open areas within MAGSA, we will also be using the NASA INSAR data to fill in the gaps. So between the two, we can verify both data sets, but NASA, since it's using satellites to determine the land subsidence within the area, it gives us a better picture of what's happening within MAGSA as a whole. So in this graph, the dashed line along the eastern edge of MAGSA is the extent of the Corcoran clay. So west of that, there's Corcoran clay, and there's 2 main, I'll say, hotspots for land subsidence. The first one is in the Tranquility area, where you see that dark red/brown color, and the second is along the southwestern boundary between McMullen and North Fort Kings. So the light green color is about 2 to 3 inches of subsidence from 2015 to 2017. And the orange-red color is anywhere from 5 to 10 inches of subsidence over those 2 years. Now this is at the tail end of the drought. So we haven't seen too much rebound yet.
And the reason that the Corcoran clay is estimated, what its extent is there to the east of MAGSA, is that subsidence, generally speaking, or actually almost specifically, is related to the loss of storage capacity of the clay layers, which in this case would be the main clay layer, the Corcoran clay, in the valley. And so you'll notice to the east there isn't any effect, because generally speaking there is no clay out there that can lose its expansive nature, but it does do that when you pump below the clay. So wells that pierce the Corcoran clay and go to waters that are in the confined aquifer below the Corcoran clay are generally the main cause that's been pointed to for subsidence, because the pressures change and it kind of squeezes some of that water out of the Corcoran clay, leaving a permanent loss of that depth, and it shows itself on the surface in the form of subsidence. And so we're concentrating, we're hopeful that we can concentrate most of our agricultural and domestic production of water above that clay, so that we don't cross over into the danger zone of beginning to decrease those pressures and increase the subsidence.
Do we have any questions before we move on?
No.
So the last portion of this session is the surface water groundwater interconnections. So here is a map of the monitoring network. We are not setting criteria for surface water groundwater interconnections. There have been a couple studies stating that it is not connected in that area. So since those studies say it's not connected, we are in the GSP saying it's not connected, therefore not setting criteria. Now we are still monitoring to see if anything changes, and we can reevaluate in the future if there are changes. There's also a new study that's being written that's supposed to come out either fall of this year or beginning of next year. So when that study comes out, we'll review that and see what the findings are. And so anything from that report would be included in the next 5-year update, so in 2025. But since the available information at this time says it's not connected, we are not setting criteria. But we'll continue to monitor according to this network.
I think of note on this one again, I'm always drawn to the fact that we even show on this map the North Kings GSA and the Gravelly Ford Water District. The way the San Joaquin River is generally operated is that the flows of the San Joaquin by and large get diverted into the Gravelly Ford area for groundwater recharge and water use. And so the area downstream of there, which directly affects MAGSA, often is dry. And so that's the key element here, is that that section of the river, that particular segment, is not continually wet. And so we don't have that interaction that might otherwise be there if it wasn't for the fact that Gravelly Ford was operated the way it was in Madera County.
All right, so we have our next live poll, and then if you have any questions, you can type that into the comment box. So of the 4 relevant undesirable results, what is your biggest concern? Is it groundwater level, groundwater storage, water quality, or subsidence? We'll give you a couple minutes to respond to the poll.
There's actually no right or wrong answers on this one. We're just trying to gauge how you see it compared to how we see it. So far, we agree.
We have a question. What is the difference between groundwater levels and groundwater storage?
The main difference being in that it is possible to have changes in groundwater storage that aren't necessarily consistent with groundwater levels. And so you can have an increase in groundwater levels and not have a concurrent increase in groundwater storage. They're both very important, and they're both one of the 6 indicators, but overall storage, generally speaking, is more of a basin-wide number, and groundwater levels are obviously much more specific to the particular areas of interest. And so they're 2 separate categories, and we can actually improve groundwater levels without improving groundwater storage if things aren't balanced in the approach. Get it? All right. Thank you. I think that's consistent with our assessment of our main concerns in MAGSA, and not to say that water quality and subsidence are not, but again, we're going to monitor those very closely, but we're going to take very active, progressive steps towards correcting deficiencies in the groundwater levels and storage areas.
Oh, so there's one more question.
All right.
Do you foresee interaction between the GSAs and the water quality coalitions?
The answer to that, I think, is yes. You can't do anything in a vacuum in the groundwater world, and so we will be very conscious of the coalitions. That's where the effective improvements in groundwater quality are intended to occur. And so the Irrigated Lands Regulatory Program and those groundwater coalitions have a much greater responsibility for trying to control groundwater degradation, much more so than the GSAs, which will be more inclined to monitor the degradation and not be so proactive in trying to correct it.